We have to prove this.
Okay, so moving on to volume of prisms and cylinders. So at the top here, you'll see I've got the formula sheet kind of underneath the packet. So the packet just looks like this. This is the top corner of the notes page, and then I slid the volume formulas underneath. Okay, we're going to make a quick adjustment here because all of the cylinder and cone formulas and even the spheres, go ahead and switch out the pi r squared for the base, except for this one. So if you want to switch that out, that's totally fine. Volume equals, and then it will be pi r squared h. Okay, so we'll add that in. All right, so now we've got our formula sheet up here. At the very beginning, this is just basically saying you can find the volume of something by adding up how many perfect cubes there are in that shape. But again, we're going over kind of the basics of the basics, so we're going to skip over this top half here and move right down to where it says the formulas. So we'll talk about the two volume formulas at the bottom. And it does have here that switched out pi r squared h formula that I just switched out on the formula sheet. Okay, so the two formulas that we're working with, the first one is volume equals the area of the base times the height. Okay, and then same thing, area of the base times the height, but the base is always going to be a circle, so pi r squared times the height. Okay, we're just going to throw some numbers on this rectangular prism just so we can see an example of this formula because there's only one in the problem here. So the area of the base, because this base is a rectangle, there's the base. If this were a 10 by 3 rectangle, you would take the area of the base, 10 times 3, and then multiply that times the height. Let's say the height is 7. So we would multiply that times 7. So that would give you, for the number, it would give you 210. And then let's say each of these was in meters. And because it's all multiplication, meters times meters times meters is meters cubed. Okay, so volume is measured in inches cubed, meters cubed, centimeters cubed. Put a cubed on the unit. Okay, let's actually we're going to do a cylinder here on the next page. Okay, so if we put the volume formula here, it is pi r squared h. So if this is our radius, then the other number is our height. That is also true if the cylinder happened to be laying on its side. The height would still be the distance in between the two circles. Okay, so don't be fooled by it if it happens to be a water bottle that tipped over and fell. Its height would still be how tall the shape is in between the two circles. So the height is in between the two circular bases. Okay, so my volume equals pi, my radius is 9, times 6. So I'm going to go ahead and multiply these. And everything on both the quiz this Friday for surface area and next Friday for volume says all to the nearest hundredth. So it's 2 decimal places. So although I would love to see this in terms of pi because it would come out really nice, that is not how it is on the practice quizzes or the actual quizzes. So I'll just go ahead and type it in. Pi times 9 squared times 6 is 1,526.8 0.81 feet cubed. Okay. Then example 3, kind of, again, it goes back to something that is really interesting. It's good to practice, but we're going down to the basics. So given the volume, work backwards to find the radius. And again, that's a great problem, but it's not a problem that you're going to have to do on a test or a quiz. So if you'd like to fast forward through this part, that's totally fine. So volume equals pi r squared h. I don't know what my r is, so I'm going to change that out for an x. My h is 2. And my volume is 128 pi. Okay, so the beauty of having things in terms of pi is that the pi's can cancel out. I'm going to take my 128 and divide it by 2. Which happens to be a super nice number. So 64 is equal to x squared. And then you take the square root to get what the radius is. So it would be 8 centimeters. Another little piece of information that's here at the bottom, but it's not a requirement. It is going to show up on an example when I turn the page, but Cavalieri's principle just says that regardless if the shape is upright, or we call it right, which just means it's right to the ground, or if it's tilted like the Leaning Tower of Pisa, you would still find the volume the same way. The volume would be the same because you take each layer and you add each layer's volume together, and the volume of this shape and the volume of that shape would be the same. Same goes for cylinders and cylinders that are what's called oblique or tilted. So oblique just means I'm kind of slanted to the side like the Leaning Tower of Pisa. Okay, so the next picture that you see, you will see an oblique cylinder. There it is. And we would find the volume the same using height of 7. So the height is not this distance here. It's not the slanted height. It's the height from top to bottom. Okay, that's pretty much it for volume. I'm going to go ahead and switch over to, if you turn with me to the practice problems. So in the practice section, it's the one that says 11.6. Volume of prisms and cylinders. Okay, again, this one goes with that very first section where you're kind of taking different little small cubes and adding them all together, which is called a composite shape, which we are actually not doing. Okay. And then number 4 and 5. Okay, again, this, especially number 4, is tricky because what is the base? So you find the area of the base, and then you multiply that times the height of the shape. The height of the shape is not 6. 6 is the height of the triangular base. So this one's very tricky. That triangle there okay, is the base, and so you would have to do the triangle formula to find the area of that shape, and then multiply that times the distance between the two bases. I know that this can be super tricky because usually you think of height as how tall something is, and it's how tall something is when it's sitting on its base. This is not sitting on its base. It got tipped over. So this is actually the height. Remember that the height is the distance between the bases. Distance between the two bases. So that's going to be 4. Okay, so if we're doing our formula for this one, the formula for the triangle is going to be half of 8 times 6 and then you're going to multiply that times the distance between the two bases, or the height of the whole shape, which is 4. Okay, and that's all you need for work. So this right here would be 1 or 2 points on a quiz, and then this would be the other point on the quiz. So these particular problems are only going to be 4 points at the most. Okay, I'm going to go ahead and turn the page. When you do a question like number 6 on a practice quiz or a quiz, again, the base is going to be this hexagonal piece here because it has its parallel partner on the back side, so it's not sitting on its base, which can be kind of confusing. But when you go to actually do this problem on a quiz or a practice quiz, it will give you this apothem number. So I'm going to give it to you right now.
I'm watching an ABC Mouse show.
So that number is 6.9 for the apothem. Just so that you have that while you're working. And if we need to do that problem on Wednesday, we can. Wednesday or Thursday, we can. Okay. Last thing I want to tell you, 7 and 8 are pretty straightforward like the ones that we did in class. It's number 9 that is also a composite shape. It's actually a really interesting problem. Problems that can be kind of stretch you a little bit mentally. But again, we're sticking to the basics since we're not together. So this, how you would do it is you would do the bigger cylinder, and then you would do the smaller cylinder, and then you would just subtract the 2. But that will not show up on any practice quiz or actual quiz. Okay, that gets you through the volume section, and you'll find another link for surface area help.